So this is video A for 7th grade 1-6 or Unit 1, Lesson 6. And your I can statement is I can simplify expressions with fractions and integers. Before we get into the lesson, I want to break down this I can statement. So if you need to pause and write it down, now is a good time to pause. Let's talk about this word expressions. And let's talk about this word integers. And these are our two vocabulary words. So you can pull definitions from my conversation right now. An expression is something that expresses a number. For example, I've just written down the number 2, but I can express the number 2 in many different ways. I can say 2 is 2 times 1. I can say 2 is 1 plus 1. I can say 2 is 4 divided by 2. So I'm going to circle the expressions that I see here. Here's an expression of 2, here's an expression of 2, so on and so forth. However, as soon as I add an equal sign, I get an equation, and equations have to balance. So if I really wanted to keep this just as expressions, I could get rid of these equal signs, and now I've got an expression here, 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 here. But I do want to point out to you, since we're on the topic, an equation is just setting two expressions equal to each other. So here I'm saying that 2 times 1, that's an expression, is equal to the expression of 2. So an expression is just a way of writing a number. Sometimes we write that number in big ways, sometimes we just write the number. And for example, I could write this equation over here. 1 plus 1, that expression, is equal to the expression of 4 divided by 2. So I hope the word expression is beginning to make sense. It's a way of representing a number. Quickly, an integer can be positive or negative, and it has to be whole. So that means you can't have part of a number. 1.5 is not an integer because it's part. There's a part of a whole associated with 1.5, but 1 is an integer. Okay. Now we've got the I can statement broke down in some vocabulary words. We're going to go to the first example. So today, I want you to be able to solve expressions that include integers and fractions. This first example has integers. And I'm going to share some strategies with you that I use. Because we can rewrite this whole thing, because you can rewrite the whole thing as addition. I'm just going to rewrite this really fast. Remember that keep, change, change? I can rewrite all these subtraction problems as addition. You don't have to, but I'm just pointing out this because I can rewrite all this as addition. The commutative and associative properties of addition apply. What does that mean for us? Well, it means that we can rearrange how we do these problems. In other words, I want to take care of all my negative numbers first, and then I go back and do my positive numbers. That's the way I do these. You don't have to do it that way. A lot of people will work left to right. They'll start on the left. They'll go, okay, what's negative 45 plus 15? And then get an answer there, and they'll keep working left to right. The way that I do it, because I think it's faster, is I do all my negative numbers and write down that one negative number. Then I do all my positive numbers and write down that one positive number. Let me demonstrate my method. Okay, so I first identify all the negative values. Whoops. Come on, pen. There we go. It's writing now. So here's all my negative values. I've got negative 45 plus a minus 23, or negative 23 plus a negative 2. And I just add all those up because they're all same sign, keep and add. That's why I like to associate the same signs together. Oops. Same sign, keep and add. I know the answer is going to be negative, but I'm going to add all these numbers up to see what the ultimate negative number will be. 5 plus 3 is 8, plus 2 is 10. And then this right here on the left is 7. So I know all these negative numbers leave me with a negative 70. And now I identify all the positive numbers. There's only 2 in this expression. There's only positive 15 and positive 7. And I'm going to erase this work over here because it's kind of confusing to have this much on the screen. Okay, so I've got my 2 positive numbers. Same sign, keep and add. 15 plus 7 gets me to 22. So then I go negative 7 plus 22. And so I've combined all my negative values, and then I've combined all my positive values, and now I've got one problem to do at the end. Different sign, subtract. Keep the sign of the highest number. So I know the sign of my answer has to be negative because my higher number, or the number with the largest absolute value, is 70. And so different signs subtract. 70 minus 22 is 48. So I know the answer to this expression is 48. So if you want to write down some steps for expressions like this, feel free to do so. The first thing I do is I combine all the negative numbers. Same sign, keep and add. Second thing, I combine all the positive numbers. Same sign, keep and add. Then I do my one last problem of different signs subtract to keep the sign of the number with the highest absolute value. I hope you caught on to that. Like I said, that's only one way. There's tons of ways you could do this. Some, if you like to, you can work left to right all the way through. That's fine too. One more example for you. What happens in expressions like this where you've got multiplication of fractions and addition? Well, we have to follow PEMDAS. And PEMDAS tells us that multiplication comes before addition or subtraction. So because of that, I'm going to do my multiplication first. So I'm going to rewrite these as fractions so I can do them a little bit easier. And then I'm going to do my multiplication. I'm going to cross factor out a 3 here. So I get 2 times 1 in the numerator and 1 times 1 in the denominator plus. Nothing I can cross factor here, so I just have to write the fraction, 20 over 7. Okay, now I have an addition of 2 fractions. I need to find a common denominator. What's a number that 1 and 7 will both fit into? 7. So I'm going to rewrite these fractions, and I'm going to rewrite this problem on the right. I'm going to multiply the numerator and denominator by 7 to get a common denominator. So 14 over 7 plus 20 over 7. Notice that this 14 over 7 is exactly the same thing as 2 over 1 because 2 is twice, or 2 times 1, 14 is 2 sevenths. So they relate to each other in the same way. Now I'm going to do my addition. 14 plus 20 is 34 over 7. Now the only step I have left is I see that this is an improper fraction here because the numerator is larger than the denominator. So I need to convert that into a mixed number. And the way I do that is I put the numerator under the roadway. 7 goes into 34 4 times. Multiply back, 28. What do I have left over? 6. Remember, the remainder goes over the divisor. So my final answer should be, and I'm running out of room here, 7 and 6 sevenths. That would be my final answer to this problem. So I'm going to just break it down real quick. I first did my multiplications. Then I found a common denominator and added them together. Every expression may be a little different, but if you follow PEMDAS and you follow some basic common sense math, you will do well. The biggest danger with these is forgetting a simple rule that you may have known in the past, like common denominators. So if you just keep all those rules in your mind that you've learned in the past, you'll do well. Last comment for you. This is not a third example problem, but you are going to be faced with some word problems, and the first thing I want you to do when you see word problems in today's worksheet is identify the important information. Then try to write your own expression that describes what's going on in the word problem, and then solve that expression. Anyways, good luck to you.